All right, so we're doing J2 of our study guide, which is a stoichiometry problem. So the question is, what volume of the barium nitrate do we need to precipitate out all of the sulfates in that aluminum sulfate? So we can think here about our reaction that's happening, and I'm just going to do the net ionic equation. So our barium ions are reacting with our sulfate ions to make barium sulfate. That's our precipitate. Okay, so the question is, how many moles of this do we have? And then from there we can find out how many moles of this we need. And if I know how many moles of this, I can use the molarity of the barium nitrate and then find the milliliters. So that's kind of my plan. So first let's find out how many moles of sulfate are in the given volume and molarity. So we have 0.35 molar equals X over 0.025. And you could use a molarity to convert milliliters to moles, like with a box chart with stoichiometry, but I prefer to do it this way. So let me just pull up a calculator. And I'm going to multiply these two together, so it's going to equal 0.00875 moles of aluminum sulfate, which is Al2SO43. So now I'm going to do a little bit of conversion, or keep in mind that this is moles of this whole thing. I have 3 sulfates in each one, so I could show that as a conversion. For every one Al2SO43, I have 3 SO42 minus ions. So I multiply my 0.00875 by 3, and I get that we need to precipitate out 0.026 moles of sulfate. 0.026 moles of SO42 minus. So what that means is, because this is a 1-to-1 ratio here in our reaction, I need that many bariums to precipitate it all out. It's a plus. It won't work with this. Okay, so that's what I gotta do. So now, if I need this many moles of the barium, then I'm going to plug in and solve for liters in my molarity equation. So I have 0.28 molar barium nitrate. It's going to be equal to 0.026 moles over some number of liters. And then I'm going to just multiply both sides by x. So 0.28x equals 0.026. Divide both sides by 0.28. It's just a little algebra. So x should be equal to 0.0929 milliliters, that's liters, which is equal to 92.9 milliliters. If you didn't round, which honestly you're not supposed to round to the very final step, but if you didn't round, you should get something like 0.09375 or something. So either answer is fine. For the AP, this is FRQ. Both would be within the range of correct answers. If you got anywhere around 93, I think you'd be totally good to go. So yeah, J2.